in the tools that we're going to be using in our coursework. Okay, when I first took this course myself in 1967, I think, I used a device that looked like this, a mechanical adding machine. Okay, actually, some of them actually had cranks on them. So you actually work them with a crank. Some later on they added electric motors to them, so you just pressed enter or plus or minus, and it would just go through the calculation. So we literally used these. Some of these were sophisticated enough that they would do squares and do sum of squares and so on and so forth. Have memories and do sum of squares as well. So that's literally what it looked like when I sat in your place when I was taking this course. We had a room full of these things, made a lot of noise. Okay, so in addition to that, we used to use a lot of other tools. These particular tools are graphic-based tools, but they're good for calculations. You'll notice that this blue chart that's on the lower left-hand side, that's called a nomograph. That nomograph is used for doing binomial probability calculations. We're going to be doing that later on in the course. We're going to be using real computers, so we're not going to be using this nomograph. One part of it, you have the number of trials that you do, the number of successful outcomes, and so on and so forth. Then you can calculate probabilities of different numbers of successful outcomes, and so on and so forth. Okay, the device, a yellow device, is called a slide rule. Probably your parents or grandparents might have had a slide rule hanging around the house at one time. How many of you have ever seen a slide rule? Not that many, right? Okay, whoever's causing that, I think I just muted you. Did I? No, could you mute whoever's, you know, I should be able to mute you from here, but for some reason it's not working. Okay. Okay, so we'll go back to this. So those are kind of tools that we started with. Okay, then electronic calculators started to appear. This is a desktop electronic calculator. First one I saw was made by a company called Wang. It cost like 30 grand or something like that to basically do what you do on your phone with your little calculator. Larger institutions, companies, insurance companies use data processing systems. This is an IBM 360. It's an early, what's called a mainframe computer. Probably in this room, you see those devices there with the red and blue circles are tape readers. They store data on tape, like audio tape, big fat 1-inch audio tape. And they would read the data on and off of them sequentially. And that big machine next to her is probably actually central processor. And in that room that's air conditioned, climate control, humidifier, probably there's not as much computing power as you have on your laptop right now. So that's what we would be using for massive levels of calculations back in those days. Okay, typically we'd be using paper, pen and paper for a lot of this kind of stuff. And we'd be using something called ledger paper, basically just paper that has rows and columns drawn on it. Okay, so you could make, for instance, if you know anybody that does any accounting, there's something called double entry accounting, where you actually have a column where you would put all your credits, and a column where you put all your debits, all the things you owe, and then at the bottom of the page you would add them up, and then put that on the next page, and add all the new ones up, and put that on, get that total, put it on the next page, and so on and so forth. And if you made a mistake somewhere in that process, well, you can't go back and fix it now because it's all written in pen and it's all set up. So what you would do if you have a credit that is invalid, the check didn't clear or something like that, you would write a line where you correct it, and you would correct it with that line, and so on and so forth. Same way with bills that you didn't pay, and so on. So it's pretty tedious mechanical process. Same thing with analyzing statistical data. When we use these columns of numbers and did our calculations on paper, it was very difficult to go back and trace our work, and also to figure out what we might have been doing wrong. So you guys, please mute your computer when you log in. Okay, so Yeah, I really don't understand why you can't. I'm not muting you. I should be able to mute you guys. But at any rate, so microcomputers started to appear in the late 70s, early 80s. One of the first major business applications to appear on microcomputers was spreadsheet programs. The first spreadsheet program to appear on microcomputers was a program called VisiCal. It would only run on the Apple II computer. That's one of the reasons why in a field of hundreds of computers, small computer makers, that Apple managed to get a big advantage, because companies would buy their computer to run this specific piece of software. And basically, it was the first translation from a ledger sheet onto a computer screen. Okay, I might have a video I can show you about that, but these are a couple of guys that invented that. They didn't patent it, by the way, or copyright it, so they didn't really make that much money out of this whole thing. Okay, so this computer ledger now got translated into what is a ledger sheet that you can put onto a screen and that you can modify. The other thing about it is that there's special properties to this electronic ledger sheet or spreadsheet program that make it uniquely qualified, uniquely good at doing engineering calculations, statistical calculations, and all sorts of other work. Now, this can be used for a lot of different applications. It's what's called a horizontal software. Okay, there are certain other kinds of software that are intended for a specific purpose. So Excel, with the spreadsheet that we're going to be using, is very good for a lot of different applications. But one of those applications happens to be statistical applications and graphical applications. SPSS, another piece of software that we're going to be using, is only good at one thing, but is uniquely good at it, and that's statistical applications. Okay, so the reason why Excel is so important is because we can embed formulas in it. We could actually do extended calculations with it. We're going to be playing around with that a little bit. Another program that's important to handling data is database programs. This can be as simple as your to-do list or your address, your contacts list on your phone. Okay, name, address, has different fields and different entries. So you could have each person that's on your contacts list. You could have first name, last name, address, phone number, Twitter account, so on and so forth. And you can have a list of all those people. That's a simple database. You can have relational databases where that information is tied into another separate file by some common number, some common denominator between each individual in this file and each individual in this file. So, for instance, if we're doing statistical work with data that involves sensitive information, so sensitive health information, we may identify a patient in our database where our statistics by simply a number. And that number separately may be held in a different file that's not published that identifies what that patient was, what his age was, what his so on and so forth, what his address was, and so on. Other specific information we don't want, to distribute with or work with on our regular data file, just thus protecting their identity. So we have regular databases, we have relational databases. Okay, and they're important pieces of software for organizing and handling data. Okay, so we just spoke about earlier, we spoke about the different types of data. Okay, we have nominal data, we have continuous or numerical data, right? And we have ordinal data. Okay, I'm going to talk about just those three kinds of data. Nominal data, basically nominal kind of implies that it's a name. So for instance, something like hair color is nominal data, right? Your hair color could be brunette, redhead, blonde, green, red, pink. It could be any variety of hair colors, right? But each one of those is a name. It doesn't have a value. There's no numerical value that makes them different. Continuous or numerical data are things that exist on a scale. Like, for instance, blood pressure is on a scale. Blood pressure could be 80, could be 110, could be 70, and so on and so forth. And in fact, it's really a continuous scale. Even though you say it's 100, right? It really could be 100.01 millimeters of mercury, right? It's really a continuous scale that's involved there. So that's called numerical or continuous data. We deal with those two different kinds of data quite differently. And it's important that we understand the distinction between them, because when we learn all the different kind of statistical tools that we have, certain tools are appropriate for certain kinds of data, and certain tools are not appropriate for certain kinds of data. So we want to make sure that we identify our data types. It seems kind of simplistic right now, but it's really pretty important by the time we get to the end of the semester that we really have a pretty good understanding of it. Now, besides numerical, within numerical data, we have other kinds of numbers or scales that we work with. And within numerical data, we also have integer data or discrete numerical data. Discrete numerical data is numerical data that's usually an integer, that's typically an integer, and it's a simple count. For instance, number of siblings, right? You have 4 siblings, you have 3 siblings, you have 7 siblings, and so on. Okay, so we have that kind of data as well. We also have, within nominal data, we can have a type of nominal data which is ordinal, which has, even though it doesn't have a specific number value, it has by its nature, the different values that you might have for it might have some sort of order to them. So for instance, if I asked you how you would rate this course, you could say poor, fair, good, or excellent, right? Well, with each one of those is a word, right? It's a name, an identification. But unlike hair color, fair, good, poor, excellent, so on and so forth, they have a relative value that we can all understand. Good is better than fair, excellent is better than good, and so on and so forth. Now, quantitatively, right, can we really measure that difference very, very easily? Not that easily, because, for instance, we don't know if the difference between fair and good is measurably the same as the difference between good and excellent. In other words, it's a judgment for every person that does it. If I ask you on a pain scale of 1 to 10, those are numbers, but they're really categorical data, but a special kind of categorical data that has order called ordinal data. So for instance, one person's 8 might be another person's 6 on that pain scale. Okay, and if you ask a patient, well, what's your pain now? It's 3. What's your pain level now? It's 5. You don't know if that difference between 3 and 5 is the same as the difference between 7 and 9, or between 6 and 8. And so you can't quantify that, but you do know that they have some order as well. Okay, so there's a lot of little extra details to identifying data types. Okay, but primarily we're going to be working with nominal data. Nominal, sometimes we'll call it categorical, or we'll be working with numerical data, or we'll be working with ordinal data. Okay, so we're going to be working primarily with data that's taken, randomly selected people from a population, or randomly selected items from a population. So a population could be everybody in this school, could be everybody in New York, could be everybody in the United States. A sample is a random sample of a small number from that larger population. So we can have the whole population, or we can have the sample. Most of the time, we're not going to have access to information about the entire population. So if I asked you, what's the average age of every person in the United States, that's not really very easily accessible to us. However, if I told you we took a random sample of 1,000 people from all over the United States and we calculated their average age, we would have an idea what the average age, we'd have a guess at what the average age of the population in the United States. But that average that we're talking about is an average for a sample from the population, not the actual population itself. So we're almost always going to be dealing with samples rather than the actual population. What is the one place where statistically we deal with the actual numbers of the actual population values? It's about to come up, right? You might have even gotten in the mail already. What's that? I'm sorry. The census, right, every 10 years, actually every 10 years. The annual census is about to come up now. In fact, there's a lot of controversy about one of the questions that they're proposing for the census about citizenship, right? But it collects a lot of the data, right? Family size, ages, a lot of other information about people as well. Okay, income information and so on. So you guys, if you weren't independent 10 years ago, you're going to be getting this information in mail. Some of you will actually get contacted for more detailed information as well. So keep your eye open for it. It's going to show up soon. Okay, so we're going to identify different kinds of parameters that or statistics that have to do with populations or samples. When we talk about populations, we call those measurements parameters. For instance, for a numerical variable, when we talk about a population mean, we're talking about, we use the expression mu. The Greek letter looks like a U, right? That would be the mean for a population. A statistic, the mean for a sample, we call a statistic instead of a parameter. And we use English letters for that. We use X for that. Okay, so if you see a Greek letter signifying a value, a statistical value, you know it represents a population. If you see a X or some other normal letter, English letter, then it's probably signifying a statistic rather than a population, statistic of a sample. Okay, so one of the issues we have is we want to be able to organize this data so we understand what it means. So for instance, if we have columns and lists of dozens and hundreds or thousands of numbers, it's very hard to interpret what that is just looking at that list of numbers. So we like to organize that data into, for instance, starting with tables, right? We want to organize it so we can actually understand it. So for instance, one of the things that we can do is we can take those tables and we can convert them into charts so that visually we can get an idea of what that data looks like. So in this case, we're talking about hair color. What kind of variable is hair color again? Nominal, right? Okay, so it's named. So what do we have here? We have a bar chart. On the bottom, we have the hair color. And on the left-hand side, you'll see that axis is the frequency or the number of people in our sample that had that hair color. So we had 2 people that had red hair, 12 people that had brown hair, and some blonde hair, 4, and black hair was about 9, right? So we can see visually relative in this sample, relatively how many people had, for instance, brown hair. Right? So it makes it very clear for us. Okay, notice that they're separated, right? Because really, they're not connected in any way. They're just different numbers. Okay, now let's take a look at another one. Oh, well, that's a whiskey bar. We have a bar chart there. We have a whiskey bar chart. We have a candy bar chart. And of course, there's one more, sushi bar chart. Okay, so let's take a look at this bar chart, form of a bar chart instead now. So what do we have here? On the bottom, we have the heights of individuals, right? These are the relative heights in, I guess, centimeters. Okay, and on the left-hand, on the axis, the y-axis, we have the frequency, number of people in our sample that had that height. So it's kind of hard to read these numbers down here, but it's 135 to 100. I'm going to say that's roughly 135 to 145, 145 to 155, and so on and so forth, just for our purposes. Right? So there were 6 people whose heights was between 135 and 145 centimeters, right? So, and we had 9 people that were between 145 and 155. Okay, now think about the nature of this. Everybody is accounted for in this population, even though it's a continuous scale. So in other words, as soon as you reach 145.4, you're in this first bar. When you're 145.5, you're in the second bar. So everybody is accounted for in this bar chart. Okay, and it's numerical data instead of nominal data. Notice there's no space between them because we are counting for every individual here. Okay, and so they're butted up against each other because somebody's going to be in each one of these things. So this type of bar chart is called a histogram. So when we're working with nominal data, we're working with, let me go back to a real one. We're working with a bar chart. When we're dealing with numerical data, we're typically displaying it or evaluating it or trying to describe it using a histogram instead. Okay, what's this, a histogram or a bar chart? But yeah, male and female, right? Okay, bar chart, histogram. Yeah, histogram, right? And it's a dead giveaway if there's space between them, you know, except that we had space in one of the histograms before. It was because there was nobody, this frequency was zero, there's no person that was actually had a weight within that range. Okay, so corresponding, we spoke about box plots briefly before. Just to reiterate, the box plot, the box plot displays the range of data that we're working with. I'm going to just talk about the one on the right-hand side here, this little red box. This little feather at the bottom represents the lowest value, which looks like it's about 11 or so. This feather at the top represents the highest value, which looks like it's about 18. So all of the people within this survey, all of the values are measured within this survey were between 11 and 18 roughly. That bar in the middle, it's a little bit heavier than the other lines. That bar in the middle represents the median, not the mean, but the median, middle value, the 50th percentile, right? 50% of the people are above it, 50% of the people are below it. This red box, the bottom of this red box represents the 25th percentile, right? 25% of the values are below it. And this, and at the top of this red box represents the 75th percentile. 25% of the people above it, 75% are below it. So what we call this red area, we call that the interquartile range. The first quartile is the first 25%. That red box is the 25th and the 75th, the second and third are the interquartile range. And the top part is 75th. Anybody want to hazard a guess of what that red dot means? Yeah, it's an outlier. It's so far away from all the other values that we're suspicious there may be some issue with that. Typically, when we're using software, you're going to notice the software is going to use some sort of a formula that's built into it to determine whether or not it's going to display this as an outlier. You can adjust that judgment. It's really up to you to decide whether it's really an outlier. The software will help you identify them, but then it's up to you to decide whether or not there's a reason for you to exclude that data from your survey. Scatter plots. It's another way to display data, right? We're going to be looking at the software that we're using and how we're going to use these different pieces of software to display data. In this case, we're comparing a husband's age to a wife's age. It's two values, two numerical values, right? So the husband might be, say, 50 years old, right? Well, each one of these dots represents a pair, a husband and a wife. And the husband's age is on the x-axis, the wife's age is on the y-axis. So I'm going to go up to here, this person over here. It looks like the husband is about 52 years old, and the wife looks like about 64 years old, right? So that dot, that dot is identified by an x value of 53, comma, a y value of 64. Okay? So we have all these different dots. Each dot represents a subject, a husband and wife, right? So what do you think you could say about husband's age and a wife's age, looking at this graph? It suggests that there's an association between a husband's age and a wife's age, right? Between two people's married ages. This is fake data. Of course, we know it would probably be a lot more scattered than this. Okay, this is called, anybody know what you might call this? This is rather than an association, what word do we use in statistics? Yeah, it's a correlation, right? And it's positive correlation because as one gets older, the other gets older too. Okay, I'm going to show you a video later in a moment about that's a really good example of using graphics or charts to display very complicated data sets. But we'll get to that. Okay, so what I'm going to do now is there are data sets that are that you can download from Blackboard. And for those you guys that aren't too familiar with Blackboard, let me see if it'll torture me and make me log on again. Nope. Good. If you go into the weekly sessions, weekly material, And session one, I'm doing this because I noticed that there are about a number of people that had never worked with Blackboard before here. Okay, if you go to the weekly sessions, so there was a folder there. Let me go back. I want to look it quickly. There's a folder in there, weekly sessions. Session one is tonight. And if you go in there to lecture materials, you'll be able to get the PowerPoint or PDF of the PowerPoint of Levi's lecture. If you go into lab exercises, you can click on that. And you'll see the PowerPoint that I just went through, but you'll also see a number of data sets here. So for instance, one, cell function, budget, graphics, 1, 2, 3, 4, and so on and so forth. Some of them are Excel files. You can see that XLSS. And some of them are other kinds of files. Okay, so what you can do is you can right click on a Mac, it's control click on each one of these. I don't know what I did there, and say save link as, or whatever turns up on your computer, and save it to your desktop. On these computers that you're using here, if you just click on it and tell it to open it, sometimes it'll open in the browser rather than in the program, which doesn't help you because then you can't really do operations with it and stuff like that. So usually it's better if you right click, save it to the desktop, and open it from the desktop. So I'm going to open one of these. I actually have them in a folder already on my desktop. Okay, if I can find it. That's not the one. Where is it? There it is. Okay. And again, most of you guys have had some experience with Excel, but not everybody. So I'll start now kind of at a different level. Okay, the first file I have is called cells and function demo. Let me blow this up a little bit. Make it easier to see. That's easier, right? Okay, by the way, if you get tired of straining from the back there and looking up here, remember, you can be looking at this window on your computer, right, by logging in to GoToMeeting, that GoToMeeting link. So you'll have a window on your computer way in the back there. Okay, so let's take a look at this. Basically, this opens up just like our ledger sheet. There's a whole bunch of columns, and there's a whole bunch of rows, just like a paper ledger would have had. Except now, we have now what we do is we identify the columns and the rows by numbers and letters, right? So right here, I've highlighted row B3, for instance, cell B3, okay, and cell C3, and so on and so forth. We can put 3 different kinds of things into these cells, okay? We can put a label. A label is just a word. I can put, for instance, January. Or I can put a number into those cells. Could be a lot of different kinds of numbers. Could be very small numbers, very large numbers, integers. Put any kind of number you want in here. I'm going to put in 345.56. Maybe that's a sales number for January or something like that. You can put a number in there. Next, I can also use those cells in another way. I can put in a function. I can put in an operation which does some mathematical function on some other cells or within itself. So for instance, I can put in a function that tells me what double that number is in the cell next to it. Well, how do I do that? Well, anytime I want to enter a function, I start by hitting the equal key. As soon as I hit the equal key, you'll notice that there's a little change up here by this row that says f of x, right? That's function of x. I hit equal signs, right? And at this point now, I can type in an operation or a function I wanted to do. So for instance, I may want it to take this number and multiply it by 2. Well, I'm going to identify that number. Rather than typing in the number, I'm going to identify it as C2, C3 rather, right? And I'm going to say I want to multiply it by 2. I'm going to say asterisk 2. Hit enter, and it multiplies it by 2 for me. Okay. So I can also do this now. If there's a problem here, that number was wrong, I can go back and I can change that number, and it'll update the cells that have been calculated based on that cell. If you're an engineer, you're designing an airplane, and you started with some modulus of expansion that was off by a little bit, and you had like 5 weeks of calculations based on that number, this is a miracle for you. I mean, when these software programs, this kind of software program like Excel came out, there was such enthusiasm in accounting, in investing, in banking and engineering. There's such enthusiasm for them, as I mentioned to you, that like they literally had computers flying off the shelves just to be able to run that software. Okay, so you can put a function in there. You can actually put a mathematical operation. You can also put in different kinds of special operations. For instance, if I wanted to know what the sine, if I have a 45-degree angle and I want to know what the sine of that angle is, okay, I can just put in sine. Well, you don't want to know something. I think it wants to know in radians rather than. Oh no, it did it. Okay, I'll do that again. Equals sine parentheses, and I'm going to tell it I want the sine of the number of degrees that's in B6. I'm going to click in there. It's going to put B6 in there by just clicking in it. So now I don't have to worry about typing in the wrong cell number or something like that. Just click in it, it'll put it in there for me. I'm going to close the parentheses, hit enter, and it tells me the sine value of the sine of that number is 0.86. Okay, well, that was pretty much a good help. What about all the other functions that, I didn't see sine here. How do I know that's there? If you click on f of x, that little f of x there, it'll bring up a box, depending on what version that you're using. This will be a big box and easy to read, and other versions won't be such a big box. But you can see here that you can list all of the different functions that you have here. So you have arithmetic functions, you have date and time functions. You can count dates up to a certain time, dates since a certain date, and so on. We could look up how many dates it is to spring, how many days it is to spring, for instance. You could, there are a variety of financial functions that are in here. There's engineering functions and so on and so forth. And we're going to get to in a moment statistical functions, average, binomial distribution, chi-square, count, F distribution, whole bunch of these things here. Let's see, max, min, percentiles, quartiles, so on and so forth. Some of these probably don't mean anything to you now, but a lot of these functions will be useful to you as we move on. Okay, next week we're actually going to use Excel and SPSS to actually start to do some problem solving in statistics as well. So I'm gonna close this out. I'm gonna open up actually, before I do that, I'm gonna go over here. The other thing I can do, which is kind of handy, is there's a lot of intelligence built into Excel where it can anticipate what you're trying to do. Like, so for instance, I have a count here and I have a unit cost, $11.20, and we sold 10 of them, let's say, right? Well, I can go in here and I can say, well, my subtotal is going to be my $11.20 times the number that I sold. Okay, G3 times F3. Again, I clicked into the boxes instead of actually typing in the G3 and F12, F3. Okay, so now I've calculated after that row. Well, this column here has counts for other transactions as well as the unit cost for those transactions. I can actually highlight the first box, drag down. I can ask it to tell it, I can tell it to edit and fill down. Now, instead of just copying down that number 112, it interprets the fact that it's next to these two columns and that you want to repeat that calculation. So the next cell has is G4 times F4, the next one is G5 times F5, and so on and so forth. Okay. How many of you guys like that this, for how many of you guys, I'm not going to ask you because I don't want to embarrass anybody. And you shouldn't be embarrassed anyway. But I'm hoping that many of you probably have seen this before, but I'm hoping that for some of you guys this is new and that this might be a good introductions and encourage you to go home and start playing with this. And just to make up like a budget, household budget or something like that, or to create lists, a phone list or something like that. Play around with this and get used to using this. I'm going to open the next file here, which is a budget demo. This is just a demonstration of the kind of what-if kind of work that you can do here. Okay, in this case, let's see, total monthly debits. So let's see, this is our budget here. Total monthly debits is the sum of all these numbers. Well, I could go here and say, It's this cell plus this cell plus this cell, and so on and so forth. However, there's a built-in function called sum. That's within those arithmetic functions. How can I find that? I can click in there and I can scroll through them, or I can do a search for it and see if there's a function like that. But if you think there is one, I can actually just type in SUM and then hit parentheses, and you'll see that the list of possible functions that start with that drop down, so you can click on that and pick one out. But as soon as I see, well, gee, sum, that's what I'm after, I'm going to hit parentheses, and it gives me a hint on how I should use it. And it tells me, well, now you got to give me, within this parentheses, a list of those numbers, that number range. And the way we give it that number range is we put a colon between the first cell and the last cell. So that would be B4, colon, and the last cell would be B9. And hit enter, and we get our total to that column. Okay, the other way you can do this is equal to sum, sum, parentheses, and I'm going to click in the first box, hold my mouse down, and I'm going to drag down to the last box, because that actually has to fill it in for me. Okay, again, reduces the chance that you're going to make an error in selecting the boxes or typing in the box location. Going to do the same thing here for credits. Okay, so we got a problem here. The balance is equal to, let's see, our credits is 1440 minus our debits, and we come up with 90 minus 340. So now we got a problem, right? We're going deeper and deeper. I know you're familiar, you're students, you got loans, I know you're familiar with this problem, right? So let's see, what can we go back here and do? Well, food, you know, yeah, rent and food, I got to eat, right? Let's do it. Let's reduce our entertainment budget a little bit, right? Okay, so let's take a couple of hundred off that. Well, getting a little closer, let's see, transportation. Maybe I can bike to work a couple of times a week, bike to school a couple of times a week, let's make that 100. Still kind of in the hole a little bit. Tuition, it's got to be paid. They have these new cell phone plans where, you know, it's not really it's like Verizon or I think Spectrum has a new plan, which is like really cheap, where like it's not really, you're really using Wi-Fi most of the time, right? And they have like anywhere where there's a Wi-Fi link for Spectrum, you can use that. And gee, I think we need a roommate. Cut our rent in. And suddenly we're in the green. This is a what-if function. It's a powerful function to use in Excel to see what adjustments you can make to get what kind of result you get. Okay, a little bit more applicable perhaps to engineers than to us, but this is another reason why these programs are so popular. Now, what else can we do with SPSS? With Excel, rather. Okay, well, for instance, this data that I have here, this is lab analyses for a mold, mold spore counts. These are done, there are instruments you can use to sample the air and capture spores and dust that are in the air, send them to a lab, and the lab actually looks at them under a microscope and actually counts the number of mold spores and identifies them. Okay, well, here's the data, and let's see. Outdoors, we took 2 samples. Fifth floor receptionist, we took a sample. Fifth floor hall, we took them in a couple other places. It's kind of hard to interpret these numbers. What am I looking at here? Well, I can highlight these 2 columns. I can highlight them this way because Excel is familiar with this kind of layout. So if I highlight them and I go into the chart function, I can ask it to give me a column chart, which is basically just a bar chart. And there, now the data is displayed graphically. And it's a lot easier to see what's going on there, right? Now I can see the outdoor levels are much higher than the indoor levels are. So maybe I'm a little less concerned than I was before. Okay, so there's a tool that you have to create a bar chart in Excel in a few moments, basically. It's a little bit more complicated organizing the data in these kind of charts, right? But especially numerical ones. But we'll be getting to that. And actually, we got better tools anyway. So I'm going to open up next one. What do we got next? Statistical functions. Well, how about that? Let's see. Let's see. I have a series of 10 numbers here, right? Okay, gee. Okay, and maybe they're blood pressures, right? Maybe we sample a small population. So we took a small sample from the population, a random sample from the population. I see those numbers, but gee, where's the middle of these numbers? What's the average here? Well, I can click in here, and there's a function called average. There isn't one called mean for some reason. There is one called average, and I can tell Excel to calculate the average of these numbers for by simply using that function that's built into it. What about the median? Equals median. There is a function called median. Parentheses, it's waiting for me to put in the range of numbers. Okay, and the median's a little bit lower. What about the mode? Anybody know what the mode is? Yeah, the value that occurs most frequently. In this case, it happens to be 80. You can see that if you look at the numbers. Okay, what about the minimum? Remember that feather at the top and the bottom? Okay, the minimum, what's the minimum? The minimum is going to be, I mean, with 10 numbers, you can just look, right? Doesn't seem like it's giving you much of an advantage, but with a lot more numbers, this actually help you out a bit. Okay, and the range is just the difference between the maximum and the minimum. So the range is 25. Okay, so there's an example using very simple techniques to produce statistical calculations using Excel. Well, that's not our only tool, fortunately. Okay. I'm going to open this is also an Excel file. Okay, this is an Excel file. It's the same file we just looked at, right? Except you notice in the top row, A1, I put BP, represent blood pressure, right? I gave it kind of a name for that variable. And each one of these are cases for that variable. Each one of these, 10 people, it goes down to 11, right? Because we started 2. Each one of these is a particular person's blood pressure. Okay, so this happens to be an Excel file. Okay, well, maybe I want to work with it in a piece of software that has a little bit more capability. Okay, so I'm going to open up SPSS. I'm gonna do this real quick because I want to just quickly go over how to get SPSS onto your computers as well. So as quickly as it opens. Okay, here's SPSS. It's opening up. You get a little identifying screen. Okay, it has a little kind of template window. You don't have to use that. It opens up, looks just like a spreadsheet, right? Looks columns, rows, and so on and so forth. It doesn't work like a spreadsheet. These cells are only places to store data, right? They don't have anything to do, they can't build a function into them or anything like that. They just store data. There's rows and there's columns. The columns represent variables. Variables could be age. Variables could be gender. Variable could be hair color. Variable could be blood pressure, and so on and so forth. Each column representing a variable. Okay. The rows represent subjects. Subject number 1, subject number 2, subject number 3, and so on and so forth. Right? So I want to get that data that we had in Excel into SPSS. A couple of ways I could do that. I could literally type it in. Right? I could just take this first column and start typing those values in vertically. Right? Or I'm going to save a little bit of time. I'm going to say open data. I'm going to open a data file. But instead of opening an SPSS data file, I'm going to go back to my desktop. Okay, and I'm going to go into that folder that I had. Where'd it go? Week. Oh, there it is. Or maybe, yep, there it is. And I'm going to look for that. Was that it? Have it there? It was on the desktop. I don't remember now. I know where it is. Let's see. It was in the folder I had on here was practice files, I think. Okay. Okay, so where's my file? I don't see my file, right? Well, my file that I'm interested in is an Excel file. And if you'll notice down here, SPSS right now is only looking for its own file type, .sav. So I got to click down here and I got to tell it I'm looking for an Excel file. And now I can see that there are several Excel files there. Okay, I'm not sure if I got the right one here, but I'm going to click on that one, and I'm going to say, let's open that file. So you got to make sure you look that SPSS is showing the file type that you're looking for. I'm going to click that, and it should import it. And no, I got the wrong file. I think it's in the different one. Let me try it again. Open data. And it wasn't practice files, it was, let's see, practice files, extra, where did I put it? Data sets. Week 1. Title 3. I'll get it. Give me a second. Where was that thing? I'm going to open it up in Excel again, so I know where it is. Oh, there it is. Okay. It was that one, I think. I'm going to open it up. Now it recognizes that it's not an SPSS file. It says, I see data from A1 to A11 in this spreadsheet file. What should I do with it? Okay, well, first thing I'm going to do is I'm going to click read the variable name from the first row of data. Okay, so it's going to read the variable row from the first row of data. Remember that little BP that I put up there? I have to tell it that that's not data, that's a variable name. Otherwise, it'll try and look at it as data. Okay, so I'm going to click OK, and I'm going to cross my fingers because I keep getting error messages. And there it is. Those 10 values have been imported into SPSS. Okay, let's see what I can do with them now. I'm going to say Analyze. I'm going to say Descriptive Statistics. I'm going to go over to Descriptives. And I'm going to move that blood pressure. I'm going to move that into this box so I can tell it which variable I want to work with. Remember, there could be a lot of variables. And I'm going to tell it that I want it to calculate the mean. I want to calculate the range. And I think that's enough for now. Let's say click OK. And an output window opens up, and it gives me what those values are. They'll be the same values as before. Yes?
So the way you did it right now, how come you can go to variable? Is it because you were importing it?
Analyze. Descriptive statistics.
No. Like I was talking about, like when you imported the data from Excel, why did you just use variable view to like alter the variable?
I'll go back there. Now you want to know the other thing that you might want to notice is that SPSS opened a separate window when it brought up the output, right? In other words, when it gave me the answer, gave me the statistics, it opened up an output window. Behind here is my data window, untouched, right? They're two separate windows. So when I save this, if I add extra data here and I want to save it, I got to remember to save my data window. And if I want to save my output, I also want to save my output window as well. We're going to talk later next week about copying and pasting between other applications and so on and so forth. Okay, so if I go back here, there's my data, blood pressure. This is my third person, the fourth subject, fifth subject, seventh subject. In the columns here are all the different values for each one of them, right? If I click down here, there's a data view and a variable view within the same window. If I click on variable view, it shows me the variables, each variable listed as a row. And in that row, it tells you the name of the variable, which is BP or blood pressure. It tells you what kind of variable it is. It tells you how much space it's allotted to it. It tells you how it aligns it and so on and so forth. It tells you what it is. Is it scalar, ordinal, or nominal? In this case, it's scalar. It's a number. Right? Identified it correctly. Each variable is going to have a line that represents its description here, right? But it doesn't matter whether I'm in the variable view or the data view. I can still do the analysis I can do these calculations by go into the Analyze column, the Analyze drop box. Now, why am I using this instead of R? Anything I do here, I can use, virtually anything we're going to do during the entire semester, you will be able to access through a drop menu here. So I can go to Analyze, Descriptive Statistics, Explore. Oops, I didn't mean to do that. Analyze, Descriptive Statistics, Explore. And I can take my blood pressure and move it in here. And I can say, okay, statistics, give me a whole bunch of statistics. Plots, give me a histogram. Okay, and let's see, I want display, I'm going to click OK. The output window is going to come up and give me the analysis that I asked for. And look at this, gave me all these different analyses, mean, median, variance, standard deviation. We're going to be talking minimum, maximum. Gave me all these calculations. In addition to that, it gave me a histogram. It decided how big the ranges would be. Right? Obviously, this is such a small data set, it doesn't look like much of a histogram. But it gave me a histogram. It gave me another form of histogram that's called a stem and leaf plot, and it even created a box plot for me. Right? So what was our minimum? Our minimum was 70. Our maximum was 95. Here's our interquartile range. And where is our median? Our median is 80. It's over here. You can't see it because it's actually the same thing as the 50th percentile or the 25th percentile. Right, so it gave us a lot of extra information, including graphical information as well. Okay, so let's finish up with, so this is the kind of stuff we're going to be working with as we move on to next week. Okay, and you guys will get a chance to do some hands-on work with this as well. I'll be posting some extra stuff that you might want to stop in on Blackboard. You won't have an assignment quite yet. But I may post something that you can start to work on anyway. Save the contents? No. Good. Yes. Okay. So I'm going to go to Blackboard. And I'm going to go to course materials. Okay, and here on course materials, a link for you to get to your textbook. It's openintro.org. You click on that. If you click on this, or you just type in openintro.org, it'll take you to a place where you can download your textbook. You also, under course materials, you have a link where you can go to download the file. It takes a while for it to download. It's a big file, the SPSS program file. There'll also be there some instructions on how to install it and a serial number that you'll need when you run the installer. Okay, so keep your eye open for that. It's sometimes a little hard to find the serial number. Okay, but you'll need that serial number. You can always go back for it as well. Okay, so there'll be versions for Mac and versions for PC, so just make sure you download the right version for your machine. There's a link and some instructions here for City Program. It's actually a site called cityprogram.org. I don't know why it has that name, CITI program.org. You can go to that site. You can create a user if you don't have it before, and you can tell it that you're interested in taking coursework in ethics and human research, keyword there, and the institution is going to be CUNY, City University of New York, and you're going to want to take the course for graduate students, and I guess any kind of graduate students. You can take social work graduate students, medical, clinical graduate students, and so on and so forth. So it should at a minimum be graduate students or above, CUNY, and ethics in human research. Okay, there's going to be animal research. There's going to be other kinds of special courses and so on and so forth. Those are the ones that you want. Okay? If you hit those three parameters, you're getting the right one. There's kind of like general instructions here on how to do this. The only problem with it is that they changed the site quite a bit. You can step through this. You can use this kind of as a guide as to what version you want to use, what version that you should wind up with. But it may look a little bit different because this is on Blackboard, so you'll be able to get to it. Again, this is in course materials. Okay, and again, you really should consider doing this early in the semester, because trust me, when you got 4 of the courses, you got projects due, it's the last week of the semester, and you haven't done this, you're really going to regret not doing it when you weren't busy now. Okay, and finally, I just want to show you a demonstration of a interesting form of graphical software. I'm gonna end the meeting here.